Good day everyone, this is exercise 11. So we have water at 200 kilopascal with a quality of 25%, has its temperature raised by 20 degrees Celsius in a constant pressure process. Now we need to find the new quality and the specific volume. So going step by step, this is state number 1. We have a pressure at 200 kilopascal. We have a quality of 25%. So these two properties are independent, intensive. That means I can use those to calculate other properties for the state like temperature, specific volume, and so on. Now the state has changed to state 2, where the temperature is the same as the first with an additional 20 degrees Celsius. We need to find the quality here, and with these two given properties it is not enough to know the state, so we have to read the question carefully. They mentioned that this happened at a constant pressure process. What does that mean is that P2 is equal to P1. So we need to find the specific volume at state 2 as well. So since the quality has been given for the first state, this means we are inside the dome somewhere here. So if we're looking at the pressure specific volume chart, then this is 200 kilopascal. And we are somehow here. If you remember, the constant temperature lines are drawn as such, and the temperature saturated can be found from the table straight away. Saturated water pressure entry at 200 kilopascal, we have the equivalent saturated temperature of 120.23. So the temperature is 100. This is equal to T sat equals 120.23 degrees. So this is state number 1. If we look at state number 2, assuming the same pressure specific volume chart at 200 kilopascal, drawing the temperature constant line, this is the 120.23 degrees Celsius. Remember that in state number 2 the temperature is 120.23 plus 20 degrees Celsius, so we are at a higher temperature line somewhere here. This is 140.23 degrees Celsius. So the only possible way that we have a 200 kilopascal and at the same time 140.23 degrees Celsius is when these two intersect somewhere here. So this is our point. This is our state. This means we are in the superheated region. So this means the quality is not defined. and the specific volume need to be calculated from the superheated tables. So here we are looking for the superheated table. We are looking for the 200 kilopascal state, because in state number 1 and state number 2 the pressure remain constant at 200 kilopascal, and we need to find the specific volume where the temperature is 140.23. Now the 140.23 lies in between the 120.23, which represent the saturated temperature. So the specific volume at 120.23 is 0.88573, and at 200 kilopascal at temperature of 150, the specific volume is 0.95964. Since our temperature lies between this range, then the specific volume is in between these two values. So we have to do a quick interpolation to find the real value. So from table B13, so we need to interpolate between the specific volumes at the saturated temperature and the 150 degrees Celsius. We found previously that at 123 the specific volume was 0.88573, and at 150 degrees Celsius it was 0.95964. So we need to find our specific volume 2 at the 140.23. Doing the interpolation, assuming a linear relationship, so working out this, your calculator, you get the specific volume.